Hi, my name is Shadrul Hisham bin Mahmud. So, do you guys know what is water? Do you guys know where water come from? How can we drink with clean water? Where is the sources of water? But
Hi, my name is Percy. In this video, we will explain about how water treatment process.
Before we start explain about how water is treated, let me explain about the basic of water.
Hi, my name is Diana Binti Irawan. So, water comes from many sources, such as lake, river, reservoir, and many more. So, in Malaysia, the sources of water is from rainfall, is from river, and also groundwater.
so, for the most important part, how exactly does one treatment plant take dirty river water or well water and turn it into water that is safe to drink and to use?
It involves a lot of processes and chemicals filter just to remove all types of contaminants. The entire process starts with screening, coagulation, flocculation, sedimentation, filtration, disinfection, and fluoridation.
We're going to explain one by one about the process of drinking water treatment.
All drinking water sources, we're going to have some of sediment, organic material. And all these material need to be removed to get clean water. Okay, next we will explain about the process of drinking water treatment. So, the first process of drinking water treatment is a pre-treatment. This process generally won't remove the large particle or any impurities by mainly physically method, which is gravity. For the surface such as rivers, seals, and sand, ejectors are being used in process to remove the large particle. However, for the groundwater source does not easily need treatment except to add in oxygens or aeration. What we need to know about aeration is used in water treatment as a pre-treatment in the process of removing iron and hydrogen sulfide. Aeration also helps to remove dissolved metals through the oxidation.
Next step is coagulation and flocculation. Coagulation and flocculation are a chemical water treatment to enhance the ability of a treatment process to remove particles. Coagulation is a process to neutralize and form a gelatinous mass to trap particles, thus forming a mass large enough to settle or be trapped in the filter. In coagulation process, a chemical such as aluminium were added into the water, which will produce positive charges to neutralize the negative charges on the particles. Then, the particles can stick together, forming a large particle which are more easily removed. Once the charge is neutralized, the small suspended particles can stick together. The coagulation process involves the addition of the chemical, such as alum, and then a rapid mixing to dissolve the chemical and distribute it evenly throughout the water. The common chemicals that are being used in coagulant process are alum, iron 3 chloride, iron 3 sulfate, iron 2 sulfate, and lime. As coagulation does not remove all the virus and bacteria in the water, it cannot produce safe drinking water. However, it is an important primary step in the water treatment process because coagulation removes many of the particles such as dissolved organic carbon that makes water difficult to disinfect.
So, the second process is flocculation. Flocculation is a gentle mixing stage that increases the particle size from submicroscopic microfloc to visible suspended particles. Coagulation of the microfloc particles cause them to bond to produce larger visible flocs. Additional coagulation and interaction with inorganic polymers make the floc size continues to build through formed by the coagulant or with organic polymers added. During this step, it helps bridge, bind, and strengthen the floc, add weight, and increase setting rate, high molecular weight weak polymers called coagulant aids will be added. Once the flock has reached its optimum size and strength, the water is ready for the separation process. So next step is sedimentation. Once coagulation and flocculation are done, the water will then flow to a tank known as the sedimentation basin. Sedimentation is a process of removing suspended particles under the effect of gravity. Sedimentation can be accomplished by decreasing the velocity of water to a point where the particles or flocks can no longer remain in suspension. The gravitational force will then pull the flocks to settle to the bottom of the basin. This process is able to remove 90% of the solids in water.
Okay, next process is filtration process. In filtration process, water is forced to pass through filter which is commonly made up of sand and gravel. There are two basic types of filtration: rapid and slow sand filtration. Rapid sand filtration is a physical process that removes suspended solid from water. It is commonly used to compare to slow sand filtration because it has higher flow rates and only requires a little space to operate. Slow sand filtration involves biological process where it uses bacteria to treat the water. The bacteria will digest the contaminant as water passes through the top layer of the sand. The disadvantage of it is it needs several days to re-establish the bacterial community after cleaning the filter. After filter is operated for a while, the sand becomes clogged with particles and must be backwashed. Flow through the filter is reversed and the sand and particles are suspended. The particles lighter than the sand, so they rise and flush from the system. So this is how the filtration process is being used inside the drinking water system.
Once water has gone through filtration process, it is most likely clean and clear. However, there might be bacteria and microorganisms remaining inside the water. The main purpose of disinfection is to kill those remaining microorganisms as well as the pathogens. Chlorine is the most common disinfectant. Chlorine is added into water and its amount and level in the treated water are monitored and controlled continuously and carefully to ensure the dose added is sufficient to kill all germs, and at the same time avoid adding excess chlorine that may affect the odor and taste of water. Chlorine inactivates the microorganism by damaging its cell membrane. Any type of chlorine that is added to the water during the treatment process will result in the formation of hydrochloric acid and hydrochloride ions. The amount of chlorine that is required to disinfect water is depend on the impurities in the water that needs to be treated. Last step is fluoridation. Fluoridation is a process of adding fluoride into the water to a public water supply to reduce tooth decay. Fluoridated water contains fluoride at a level that is effective for preventing cavities. Fluoridation does not affect the appearance, taste, or smell of drinking water.
In conclusion, clean water is one of humanity's most fundamental needs, and those of us who live in urban areas usually get our water from some kind of centralized public system. The access to fresh water is one of the largest drivers of making a modern society. Operating a water system is a major responsibility that has implications for public health and safety. Water treatment is needed as we've been using it so often, like day and night, on weekend, holidays, and any time in between. Lastly, we hope you guys enjoy our video. Thank you for watching and let me know what you guys think about our water treatment process. Thank you.